So let's look at an example really quick. I have a erased. Okay, so once upon a time, there were, these are probably going to fall off like 3 times to your enormous amusement, I am sure. But,
Good.
so you got that to look forward to. Alright, so before we were talking about, we did some of those diagrams. We did sodium, for example, and chlorine. That's what we're going to do. We're going to make some sodium chloride and show that the reason sodium chloride forms is so that everybody's happy. Like here's sodium. It was number 11. It had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1 out here. Yeah, we'll do that one in red. And we've got chlorine over here. Here is chlorine's 1, 2, 3, 4, 5, 6, 7 electrons. All right, so here's the question. What would make chlorine happy?
Water.
Have one more.
One more, right? Because if it had one more, it would move over from the being like chlorine to being like argon, which is stable and happy. See, the noble gases are like the rich people of the periodic table. They don't have to go anywhere. They don't have to do anything. They just sit there. They're stable. They're happy. And everybody else got to go to work. And so chlorine's got to go to work, find itself an electron, because they really are happier that way. Yes?
Can I go to the bathroom?
Yes. Okay. And sodium also has got this shoe in the dryer thing going on. It's got this 1 extra electron. If only it could lose this 1 extra electron, it would be stable and happy. Well, guess what? They, once upon a time, chlorine went to a party and it ran into sodium, and they bump into each other, because that's how chemical reactions actually happen. Is when atoms run into each other in just the right way, and chlorine's like, hey, nice electron.
Oh yeah. Nice electron.
And sodium says, I can't believe I'm going to put this on the internet. I was hoping I'd lose my electron today.
Oh shoot.
I know.
You're not going.
Oh.
And so it does.
And they both become.
And they, and all of a sudden,
Whoa.
That electron baby.
no, it's nothing like that. I can't even fake outrage after what I said. But yeah, so here's the thing. Chlorine or sodium loses that electron, and all of a sudden it has a full outer shell. Chlorine gains an electron, all of a sudden it has a full outer shell, and they're super happy. And
they never see each other again?
well, no, they do. That's the thing. They stay with each other for a long time. Once they go together, so why do they go together? And this is, well, then we're going to go for like 1.5 more minutes. What? Okay.
They go to, wait, what was the question again?
Why do they stay together?
Because
They've exchanged electrons. Why would they stay together after that?
only the electrons place that. Yeah,
it was
so
good
if
sex.
they separate them, the other one gets the electron.
That's good,
Right?
man.
It's not. No, it's not a possession. It's not a possession thing. It's
A chemical
It has to do with the
bond.
number of electrons, right?
It has to do with the number of electrons. It is a chemical thing. But okay, let me ask you a different way. So we used to have 11 protons and 11 electrons. Now we only have 10.
Oh, the unstable?
What does that change?
No.
Changes the
Stable
number.
now.
It changes its,
The charge.
Explode.
It's
Changes the charge. Is that
Oh, yeah.
covered?
No.
Yeah.
Oh, I got it.
Well,
Trevor's
it
so smart.
changes the charge. So think about it this way. So here you are. You got 11 protons and 11 electrons. You take a negative electron away. What are you?
Positive.
Positively charged. So this becomes sodium plus 1 ion. And an ion is just a word for an atom that loses or gains an electron. And then chlorine, of course, has gained an extra negative, so it becomes negatively charged. So it's Cl minus 1. And so, right, because you have an extra negative charge, so you're negative 1, you have a 1 less negative charge, so you're positive 1, and now they are attracted to each other basically forever.
What is the...
until something better comes along.
Oh.
It
Because
really do be like that.
just like any other
Oh,
pair,
Oh.
there are elements that chlorine is more attracted to, like francium, for example, or francium, if you will. Francium also has one outer electron, and francium's really dense. And
Oh.
chlorine likes
A lot of
that.
moolah. It's got that.
Likes the
Chlorine likes
density.
that, right? And the French accent. No, nobody can resist the French accent. Hello, I am Frenchy. Would you like my electron? Huh? And anyway, and so.
Oh, what is this?
And so next thing you know, sodium's home crying in front of the television, and with its electron back, by the way. Chlorine's like, you can take your electron back because I found somebody I'm more attracted to.
You can't just
And
give back
so
your electron.
Sodium gets its electron back. It's no longer an ion.
That's
It
not
goes home.
possible, really.
It cries,
Oh.
it cries in front of the television, and
Zoom in on
francium chloride is now a thing. But anyway, but the thing is, let's go back to happier days when they were
Yeah.
still together.
Yeah, can we please? I'm a little bit depressed.
Yes,
Oh.
let's reminisce about when they were still
Didn't know you're
together.
taking the whole electron thing serious.
Are you
You lose an electron?
I'm okay, I'm getting a little emotional.
Got him, coach.
But, so you had your sodium
Yeah, like
chloride
I'm
here.
telling you.
You got your sodium chloride in.
Wow, what's that even going to mean?
All right,
Why
whoops,
would I
that's
use
Na
No, it's
plus one.
just not that.
Damn it.
Okay. It's not the best.
We're not cutting this.
Na plus one.
Yeah, we're absolutely not editing this.
We're almost done. And let's put
Oh, that was
francium
such a
back.
bad advice.
So here's the thing. This is really stable, actually. This, barring francium or something it's more attracted to coming along, or passing a bunch of electricity through a solution of it, which will separate it. This is going to stay together. You can heat this up to about 3,000 degrees, and it'll just sit there. Doesn't, eventually it'll melt, but it'll still be a stable compound. So unless you introduce electricity or a better source of electrons, like if I start passing actual electricity through this, then it'll change the situation. But anyway, that is how chemical compounds work. And why don't we take a break? Thank you very much.
Yeah.
Something very cool.
Yeah.